Hi, in this video I'm gonna go over the scalar product of vectors. Okay, so now we are pretty familiar with vectors, and now then that brings us to the next challenge, right? So for example, if I have a vector A goes that way and I have a vector B goes that way. Now I know what happens if I have vector A plus vector B, right? Oh, let me just do that again. Let's say my vector A goes that way, my vector B goes that way, right? By now we can add vectors, we can subtract vectors. But what if I bring this vector next to my vector A, like that, and I actually want to find the angle between them, right? The angle between this vector A and vector B. But this is when scalar product is helpful. Okay, another name for scalar product is called the dot product. The dot product. Okay, so you guys need to know both names. Okay, so scalar product says this: when I have my A dot, let me just write this down. When I have my vector A dot my vector B, my vector B, this is equal to the magnitude or the length of vector A multiplied the magnitude or the length of vector B multiplied by the cosine of the angle between them, right? This angle between them, right? This is the angle between them. Okay, so this is simply what scalar product is. So as you can see, we have been dealing with cosine, sine, cosine, tangent for a while already. So, and we can get the angle between them from there. Okay. Now, another way to find the scalar product is this. So let's say today my vector A, in this case my vector A, let's say it has a vector in terms of column vector form, AY and AK. Sorry, AZ should be Z. So X, Y, Z axis, right? AZ. My vector B has BX, BY, and BZ. My vector B in column vector form is like that. Now, to find the dot product of my vector A dot vector B, all I have to do is to multiply the X components together. So AX multiply BX, right? Plus my AY multiply BY, the Y components, plus my AZ multiply BZ, my Z components. Okay? And that's it. This would also give me the dot product. So even though it looks as if we have two ways to find them, but in fact they are actually very, very much connected. Okay, so let's look at an example, and you guys will see how they are connected. So let's say today my A is equal to, let me change the color, change to green. Let's say my A today is equal to 1, 4, and -2. And let's say my B is equal to, say, 2, 4, and 6, right? 2, 4, and 6. And they want us to find two things. The first one is A dot B, okay? A dot B. And the second one, the angle between them. Angle between them. Vector A and angle vector B. The angle between vector A and vector B. Okay, so let's do the first one. So for part one, vector A dot vector B is simply equal to 1 times 2 plus 4 times 4 plus -2 times 6. And that will give me 6, right? That gives me 6. And that's it. So you guys might find this weird, right? When I dot two vectors, when I'm finding a scalar product, my answer is actually just a number, which means a scalar, right? And that's why we call this a scalar product. For those of you who are doing physics, you might have come across something that's called a cross product, which is not part of the IB Math SL syllabus, so we're not going to talk about it. But if you want to know more about it, feel free to come and talk to me about it, okay? So for the IB Math SL syllabus, we will only be talking about the scalar product. So when I find the scalar product or the dot product of two vectors, I have my answer would be something scalar, or number. In other words, it'd be just a number. Okay. Now for part 2, they want us to find the angle, right? They want us to find the angle, so which means we're going to use this right there, right? So I'll have to find the magnitude of my A and the magnitude of my B. So let's find the magnitude of my A. You guys should be able to do this now. So pause the video, and I want you guys to try and find what's the magnitude of A. All right, magnitude of A, magnitude of B. Pause the video and find those magnitudes. Okay, so I hope you have found the magnitudes. Your magnitude for A should be square root 21, right? And your magnitude for B should be square root 56, right? Okay, so, and I have just found my A dot B. My A dot B was 6, so I will have 6 is equal to, let me rewrite that. 6 is equal to my magnitude of A multiplied by my magnitude of B and multiplied by cosine theta. So my cosine theta is equal to 6 over root 21 times root 56, right? Which is equal to 0.17496 blah 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 blah, right? So my angle theta would be arc cos of that. Let me write that somewhere else. My angle theta is equal to arc cos of 0.17496 blah blah blah. So my angle theta is equal to arc cos, and that gives me 79.9 degrees. Okay? So my vector A is here, my vector B is there, and the angle between these two vectors is 79.9 degrees. Okay? All right. That's it for now. The next part is relatively simple because a lot of times the question will ask us to prove that two vectors are perpendicular or parallel, right? So if two vectors are perpendicular, which means 90 degrees, right? That means 90 degrees between them. And if I have my vector V dot my vector U, that would be my magnitude of V multiplied by my magnitude of U multiplied by cosine of 90. What's cosine of 90 degrees? I hope you guys know this on the top of your head. Cosine 90 degrees gives me 0, right? So this whole thing becomes 0. So if they want us to prove that two vectors are perpendicular to each other, all we have to do is to carry out the dot product, and if it happens to be 0, if your result of the dot product is 0, then that means they are perpendicular. What if they're parallel, right? In this case, my vector U is in red, my vector V is in blue, and they seem to be parallel. So if they're parallel, so vector V dot vector U is equal to my vector V, the length of vector V, the length of vector U, cosine of what? Right, cosine of what? If they are parallel, then they are pointing to the same direction, right? They are pointing towards the same direction, which means the angle between them is actually 0, right? There's no difference in terms of their directions, right? Whereas in the perpendicular scenario, one goes straight to the right and my V goes straight up, the angle difference between them is 90 degrees, right? So in the case of parallel vectors, the angle difference between them is 0 degrees. Cosine 0 degrees gives us 1, right? So when you carry out the scalar product or the dot product of two parallel vectors, you're basically finding the product of their respective length. Okay? That's it. I want you guys to try this out. So we have the univectors of x-axis, so I dot I, univectors of the y-axis, j dot j, and univectors of the z-axis, k dot k. I want you guys to give it a try, and let's see what you get. All right? All right, that's it. I'll see you guys in the next video. Bye.